Howdy, y'all. Welcome to another episode of My Hands, where you get to look at my hands, do some math. We're going to talk about simplifying rational expressions. Rational expressions are, one function over another. So something like that was what we'd kind of refer to them as. Now, I'm going to back up. We have our note sheet, but I want to talk about what does it mean to simplify a fraction. When you take something as simple, or you don't have to think of it as simple if you don't want, as 4/8. Well, we think about that as common factors. And when we think about multiplication here, so they both have a common factor of 2 here. And they can have several common factors of 2. This one has one extra. We'll leave an extra 1 right here. When we think about multiplication with fractions, it goes both ways when we think about a fraction times a fraction, such as something like a times b, a over b times c over d. We squish together and we say it's AC over BD, right? Well, that's actually a two-way property. We could also say this can go backwards. And so when I look at this was like the result of squishing things together. And realistically, we could think of it like this. Now, what we know about a number over itself, so something that's equal to 1, these are all equal to 1, and multiplying by 1 is redundant. So that idea of crossing out things the same on top and on bottom is because we're multiplying by 1. And I want to emphasize that whole idea about multiplying when we get into what we're talking about. That whole concept, that doesn't work the same way as if I was talking about addition. So even though 4 could be considered, 2 plus 2, and 8 could be considered 2 plus 6, right? This is still 4 over 8. This does not work. If I just start crossing things out here, we know for a fact, just by logistics, that 2/6 is not equal to 1/2. This does not make sense. So be careful. That's my warning first. When there's pluses, it doesn't work. The idea of crossing out common factors is because we're multiplying by an identity of 1. So there's my little disclosure. So how does that look when we have something like this? Well, there's a bunch of minuses. Even though these x squares are similar and there's, I see some 4s, they don't necessarily cross out immediately because it's not multiplying by 1. So what we have to do is we have to think about this trinomial and binomial as factors. And so we have tools to factor those, right? We use our little diamond problems, however you like to do it. Now I'm going to use the shortcut method because this is a leading coefficient of 1. So I can just kind of go from the diamond to the factorization. So two numbers that multiply to negative 12 and add to negative 4 would be negative 6, positive 2. So I say my top is x minus 6, x plus 2. And the bottom is the difference of squares. If you forgot about what the difference of squares is, it says a squared minus b squared is a plus b, a minus b. So in this case, it'd be ax minus 2, x plus 2. And I've lined this up nicely. Now this is a multiplication. Yes, there are pluses here, but they're grouped all together. And so I'm going to go ahead and say that these divide to 1, and I am resulting with this. Again, we don't cancel anything else out here because this is not multiplying by an identity of 1. There's an identity kind of 1. It's not really because there's no multiplication here, but we can't divide those out because of the subtraction. If that was multiply, if this was 6x over 2x, yeah, by all means, cross them out, but we can't. So let's look down here. This is properties of exponents. So realistically, we're going to have to remember the first property. We've talked about different properties that like a of n times a of m, a to the m, sorry, we add their exponents. So I'm going to go ahead and add a bunch of exponents. I'm also going to leave these things factored. I'm not going to combine them at any rate. So I'm going to leave that as 8 times 7 times 56, and we'll just see what pans out. And we'll leave the bottom as 2 times 4 times 8. All right, let's count up our x's. We got x to the third here. We add up x to the fourth, so that gets us to the 7th. We have another x to the 7th, so that's x to the 14th. All right, y's. We have 1. Now we're at 4. Now we're at 8. So I just added their exponents. 1, 2. And then 2, 7, 14. All right, looking pretty good so far. Now you may remember the property that says if I have a quotient of two similar bases, we can subtract their exponents. So ultimately, two of those x factors are going to cancel out. So we'll have x to the 12th. And the 8 on top will cancel out. So we will have 6 on the bottom. So let's get that going. So we have 8 times 7 times, and you know what? I'm going to go ahead and break up this 56 into 8 times 7. So I'm going kind of an interesting way there. So again, 8 times 7 is 56. On top, we now have x to the 12th because these divided out. So 2 of them got subtracted. There's no more y's on top. All of those are divided out. And I'm going to combine these. I'm just kind of looking with a little foresight here. Like that. And then we have y to the 6th. All right, I'm going to take care of my numbers here. Again, we could have dealt with these numbers in a different way, but I kind of set it up so that I saw I have a bunch of 8s. And now what we are left with is 49 x to the 12th, y to the 6th. If we have two rational expressions being multiplied by each other, the simplification is very similar to here. The first step that we're just going to think about is factoring. Factoring looks a little different depending on what we're looking at. Up here, it's just the greatest common factor of 3x. So I'm going to take a 3x, and that's going to leave me with 1 minus x squared. On bottom, I'm going to start doing these diamond problems in my head. Two numbers that multiply to -5 and add to 4. Well, that would be -4 and -1. So I'm going to have x minus 4, x minus 1. Two numbers that multiply to -20 and add to 1, x minus 4 and x plus 5. And the 3x doesn't need to be factored. All right, now when we get down to this, I want you to remember that multiplication is commutative, meaning we can do it in any order. These don't have to be stacked directly on top of each other because they're all a part. I'm just going to go ahead and straighten that, say times. One big string of multiplication. So as long as like there's not a plus that's outside of the parentheses, we're good to start dividing things out. So here, that's going to divide out. And I did make a small mistake up here. If we look right up here, I factored out the 3x. I never ended up factoring out that x squared. I factored out one of those x. So this is 1 minus x. Let's go ahead and just clean that up real quick. All right, so we got our x minus 4s canceled out, our 3x's. Now, these look really similar, but that could be, we can't quite say they're the same. They're not the same. 1 minus x. Subtraction's not commutative. The order matters. So at this point, we're just going to go ahead and leave this as 1 minus x and x plus 5 all over x minus 1. So those are opposite factors. They do not cancel out. They're not the same. Let's look here. So this guy right here is essentially in a numerator. So we're going to kind of leave it like that. Now we're going to do some factoring. Now this one's kind of a tricky one. Let's get the top first. This guy, we got our x plus 2 up here. That doesn't factor. But that one, let's see, does that factor at all? Actually, I don't think it can because, well, look how small that is. 3. Numbers that multiply to 9, they're all bigger than 3, and that's a positive 9, so we're kind of stuck there. We might have to remember some other fancy types of factoring, such as the difference of 2 cubes. If you forgot this one, no biggie, that's going to happen. So that formula says this. Here's the difference of 2 cubes. And now our b in this case is 3. Okay, so we're going to have x minus 3 times x squared minus 3x plus 9. And I'm sorry, this is a plus right here. And whoa, look at that. How convenient. We have common factors now. So we have x plus 2 over x minus 3. Boop. Now we got some dividing. Look, we're going to throwback switch. Remember that whole thing? I think a lot of people might remember a saying called keep, switch, flip. I don't remember if those are the actual words you use, but we're going to keep the first one the same. We're going to change this to a multiplication and flip that. So 8/3 times 9/5. Now I could go ahead and multiply this straight out. I like to leave things factored in case, just to save myself some extra effort. 9 is the same as 3 times 3, and I have a 3 down there and a 5. And we'll go ahead and say boop, boop. Now I know that if I factor down 8, it's going to be a bunch of 2's, and well, that's not going to cancel out with a 5, so we'll just leave this now as 24 over 5. So same property applies here. I'm pretty sure I just said property. I don't know what that word is. All right, so let's flip this guy. 12x y to the 7th, 18 xy. So I want to emphasize you can go about ordering order. Earlier in this note sheet, I combined all my x's and y's first. I could start canceling out if I wanted. I could do boom, boom, cancel that out, change this to a y to the 6 and cancel that one out. These y's can cancel out, and this can go to x squared. Okay, a little messy there. But the main concept is that the order of which we do things doesn't matter too much in this. And I have a y to the 6th. Sometimes it gets a little harder to track what you have still, though, so might be careful there. I got an 8. Cancel it out, cancel it out, cancel it out, cancel it out. Okay. All right, now we're just left with some other numbers. Well, depending on the method you like to use, you could go straight from here and look at common factors. You could even factor this 18 into 9 and 2, and you could factor this 8 into 4 and 3. Why would I do that? Well, let's see. If I can't turn my 12 into a 4 and 3, and I change my 8 into a 4 and 2, and my 18 into a 9 and 2, this is exactly the same as this. I just didn't change. I changed by factoring some numbers. So I knew that there would be common factors that could divide out. And we're left with just 3x squared minus, or not, no minuses in that, I'm sorry. And ta-da, completely simplified. Let's continue to the other side. And we're going to make this a second video. So we'll come back on this one so you have 2 videos to look at.